Today's lesson is section 4.4, polynomial factoring. Got two new factoring formulas up here. The first one is called the sum of two cubes, and here's the formula for it. I want you to study that, and there's an example next to it. The other is called a difference of two cubes. Here's the formula example next to it. After you study that and look that over carefully, let's try to use it in some factoring questions. Okay, so what we're going to do now is we're going to delve into factoring higher degree polynomials. This is kind of a review topic because we have factored quadratics already in the past. And this will all lead us to the ability to solve a higher degree polynomial if it's able to be factored. And then we'll have techniques if it's not. So number one, this problem is a sum of two perfect cubes. Now, the reason why I know that is that the first term is a perfect cube because it's written as a cubed. The second term could be written that way. Now, I want everybody to think about this. What is the cubed root of 27? Or in other words, what number multiplied by itself 3 times would give you 27? And that answer is 3, right? So 3 times 3 is 9 times 3 is 27. So what we see here is that this formula, as I've got it written over here, will work for this situation. I mean, we see the A's right here, right? And then the B's would be like this, 27 turned into a 3. So this would be the location of those 3's. Now, what I'm going to do is show you how we can write this in factored form. Actually, what I can do is just slide everything over here underneath this formula, and you'll see how everything fits together. So it is a sum of two perfect cubes. So what I do first is I'm going to write a binomial, and that will be a plus b, or in other words, a plus 3. You're using the cubed roots. Then the other part of the factoring formula is a trinomial. You'll see at this point right here, you write a squared. At the end of the trinomial, you have b squared. Now, b is 3 in this case. So that would be 3 squared, which is 9, plus 9. Now, look in the middle of the trinomial. Notice that sign is the opposite of that. So we're going to put a minus, and we are writing a times b. That's the two cube roots multiplied together, which in this case is a and 3 multiplied. There is the factoring formula. This is the answer, everyone. A binomial times a trinomial. That's something new. You're going to get used to it, but that is what's called a sum of two perfect cubes. Let's go down to number 2. I think we're going to end up using the similar formula. It's called the difference of two perfect cubes. But right now, that's not the situation in this binomial. Who knows what we should do first? We need a greatest common factor because there is one in this case. And I'm thinking that both of these are divisible by 6 and z squared. What do you think? I believe so. So we'll use 6z squared as the greatest common factor. And then on the inside, let's go ahead and do some division. So it'll be 5 minus 2 would be z to the third. There's a perfect cube. Minus 750 divided by 6 would be, I believe, 125. Let's see here. 1, I believe so, and the z squareds cancel out. So we do have a difference of two perfect cubes in this case. So I could rewrite it a little bit differently to show you that. This would be 6z squared. That's got nothing to do with the factoring formula. But we have z cubed minus, now what is the cubed root of 125? What number multiplied by itself 3 times would give you 125? It would be 5. So let's make this clear in this situation. This in the formula will represent A, and that 5 will represent B. So what I'm going to do is write the factorization of this. So the 6z squared is the greatest common factor. That needs to be there. Now I'm going to write my binomial, this right here. That will be z minus 5. That's the two cube roots. Now everybody open up a trinomial. A squared. In this case, that would be z squared. I'm going to go to the end, and it'll be plus b squared. So that'll be plus 5 squared, which we know is 25. Now look at the middle term, everybody. See how it's a plus? So that sign is different than the lead sign. And it's a times b. In this case, that'd be z times 5, which is 5z. There is the fully factored form right there of that expression. All right, let's try a couple more. How about this question here? Now that should look familiar to you from a few months ago. Do you remember how to factor an expression that has 4 terms? All right, we've got to use grouping. Let's go to it. So what I would do is I would put some parentheses around the first group. Now, do you remember what happens if that middle term has a negative? I don't know if you do, but when you group this, you just changed it. So you need to change that sign to keep it with the same value as the original problem. That's if you have that middle sign right here. That's a negative. That caused you to do that. All right, let's get some greatest common factors. What's the greatest common factor in the first expression? That's right. It looks like it's x squared, right? So if you divide those by x squared, let's rewrite this. X squared, x plus 4. And I don't see a greatest common factor in the other expression. Do you? No, I don't. So we're just going to rewrite it. But I'm going to squeeze a 1 in there, okay? Nothing wrong with writing a 1 in there, is there? Now, when I'm looking at this from the perspective of greatest common factors, do you recall that in this term, you see an x plus 4? In this term, you see an x plus 4. So x plus 4 is the greatest common factor. And what is left over? X squared minus 1. Okay, so you think we're done? The answer is no. These polynomials are going to go a little bit more in depth than what we have seen before. This expression right here is factorable. Does anybody remember what that can become? So the first expression is there. The highlighted expression is a difference of two perfect squares, x minus 1, x plus 1. There is the answer to this problem. So these are going to be a little bit more in depth than what we've seen in the past. Try number 4. That's very similar. Okay, so you should have done some grouping here. Since the middle sign here is a plus, you don't have to worry about changing the sign on that 3. So did you find the greatest common factor? It'd be y squared for this, wouldn't it? All right, let's factor it out. Y squared, that'd be 3y plus 1. And then the greatest common factor over here should be a 3. Let's Pretty straightforward. I see the 3y plus 1 is the greatest common factor, and this y squared plus 3 is left over. And that's as far as you can go. I don't see any other factoring formulas that would work. That is fully factored, everyone. Let's go down to number 5. What do you think we could do there? Do you see anything that would be helpful? Well, I'll tell you one thing that's bothersome is that if you ever have a negative number in the lead position, I would factor out a -1. Very difficult. So take a greatest common factor of -1 out. It's very difficult to factor with a lead factor that's negative. Does anything else jump out at you as you look at this? Okay. I'm kind of thinking that might be a difference of 2 perfect squares. When I look at this, there's a square root for that term and there's a square root for that term. So I'm going to try that. I'm going to see where that gets me here. So I know I've got my greatest common factor, and I'm going to use my formula for the difference of 2 perfect squares. Square root of 16n to the 4th would be 4n squared. The square root of 625 is 25. Difference of 2 perfect squares. Now I'm telling you what, I think we can go even a step farther, because this expression is also a difference of 2 perfect squares. Let's go one more step. Greatest common factor. This will break into square roots 2n and 2n, minus 5 and plus 5. And then the other expression, 4n squared plus 25. That's the final answer. A little bit more complicated than we're used to, right? But we can do it. Looks like we got another problem down here. You think about number 6. Any ideas out there? Greatest common factor. I think we've got one that we can take out of here. I think it would be a 5 and a w squared. What do you think? Let's take that out front as the greatest common factor. Let's do a little division. So let's see, that would be w to the 4th minus 5w squared. So cancel out, plus 6. Okay, we're not going to be done here. I want everybody to look at this carefully. Of course, we have our greatest common factor that will remain. But what do you notice about this trinomial? What do you think? I'm thinking we could factor it like a normal trinomial if it were quadratic. So here's what I mean. Okay, so here's what I want. I want this w to the 4th to be broken up into w squared times w squared. That makes sense, right? 2 plus 2 is 4. Now what I want you to do is come up with 2 numbers that multiply to give you 6, add together to give you -5. Finished. That is done. Okay, it's time for your homework.